All right, today we're going to talk about radical expressions in rational exponents, section 8.6. Okay. We have done a little bit of work with radical expressions and rational exponents in respect to solving. Okay, today we're going to look at just kind of what individual expressions mean. So radical expressions and rational exponents, and they are very much related. Okay, there's just kind of a difference in how you write them, but they are two and the same essentially. Okay, section 8.6 here today. Bless you. So here we go. Radical expression. A radical expression means it is written as a root. Okay, so a radical expression means it's something written as a root, like the square root of 4, for example. That is a radical expression. We have already, up to this point, we've solved, for example, like the square root of x plus 2 equals 10. We did some of that right before break hit, where we solved those radicals. Today, however, we're going to be focusing in on solving just a basic expression. All right. So this is a fourth root of 81x to the 8th. Now you take this into steps, basically take it in strides. For example, first I would take the fourth root of 81. So what number is the fourth root of 81? Essentially what that means is what times itself 4 times gets me to 81. Okay, so you got to think about a number. What times itself 4 times is 81? It is 3. Okay, if you see down here, it is 3. The number part's really probably the toughest part of all this. Because the variables, it's really not that bad. What I mean here is I have the fourth root of x to the 8th. And you're like, well, I have no idea. We're talking about variables there. That's tough. When you have a radical and you have variables, all you're going to do is divide. For example, what is 8 divided by 4 get me? 2. So my answer here is 3x to the 2nd power. Okay, when you have a variable with respect to radicals, you're just going to divide it. Okay, so I'm just going to take x to the 8th divided by 4, and I get x squared. So basically what it means is x squared to the 4th power, or x squared times x squared times x squared times x squared would give me x to the 8th. It's the same thing. All right. Quotient power, you can do the same thing. That was the product property. That was with multiplying, respect to multiplying. Quotient, again, do the same thing here. If you notice, I have the cube root of x to the 9th. What does 9 divided by 3 get me? 3. Recognize that becomes x to the 3rd there. Okay, and again, the variables are fairly straightforward. Numbers. Now again, remember, we don't like radicals in the denominator. Does everybody recall that? No radicals in the denominator. So usually what we've done is we've always multiplied the numerator and denominator, right? For example, up to this point, I think if we had, let's just go like 1 over the square root of 2. I would take that times the square root of 2 over the square root of 2. Does everybody agree with that? We've done that before. Notice, what did they do here, though? They had to multiply this one by 3 times. Why did they have to multiply this one by 3 times, you suppose? Because what type of root is it? It's not a square root. This one was a cube root. So when you have like a cube root, you have to multiply it by 3 times. If I had a fourth root, how many times do you think I probably got to multiply it by? 4 times. If I have a fifth root, I need to multiply it by 5 times, just to get rid of it, basically to eliminate it. That's all that's saying. The variables, though, are still going to be all the same. Okay, the variables you're just going to divide and eliminate, essentially. All right, so let's look at number 1 here, radical expressions. So number 1, I have the cube root of x to the 8th times the cube root of x to the 4th. Recognize, when I multiply, what do I do with exponents when I multiply? When I multiply exponents, I add them. Thank you. So the cube root of x to the 8th times x to the 4th really gets me the cube root of x to the 12th power. 8 plus 4 is 12. And now it's a radical expression. I'm going to divide the exponents. What's 12 divided by 3 get me? 4. So this gets me nothing more than x to the 4th power. Okay, it's nothing more than x to the 4th power. Now, number 2 is probably the toughest one you will see today. Okay, and why is the toughest one you see today? Because there's one of those dang radicals in the denominator. All right, let's simplify the numerator first, though. Okay, I have the fourth root of x to the 8th over 6th. If I look right here, the fourth root of x to the 8th, I can simplify that. What is 8 divided by 4 going to get me? 2. So this really becomes x squared over the 4th root of 6. Does everybody understand where I got x squared at there? Basically took 8 divided by 4. Yes, sir. Okay. Now, I need to get rid of that radical in the denominator. So I'm going to have to multiply the numerator and denominator by what here? The 4th root of 6, right? So I need to take this times the 4th root of 6 over the 4th root of 6. And how many times am I going to have to do that? 4 times, right? Because it's a 4th root, so I have to do it again. And again. And again, notice we have 1, 2, 3, 4 of them. Why do we have 4 of them in the denominator? Because it's a 4th root. If it was a square root, we'd only have to have 2. If there was a cube root, we'd only have to have 3. But it's a 4th root, so we need 4 of them. Okay. Now, because it's a 4th root times a 4th root times a 4th root times a 4th root, I'm going to be left with a 6 in the denominator. So I'm left with x squared. Now, the 4th root of 6 times the 4th root, I'm going to looking at my numerator right here. So what is 6 times 6 times 6? 6 times 6 is 36. Take that times 6 again, and does anybody know what I get? 216. All over 6. Okay, and that is my final answer. Now, that one is probably the toughest one you will see today. Okay, and again, why is that? Well, because I had a 4th root in the denominator, and it kind of gets really messy, especially with a 6. Like a 2 or a 3, it's not too bad, but a 6 kind of gets a little bit rougher. Yes, sir? But because I'd multiply them all, and the 4th root of all that would still come out to be 6. Okay, let's start with number 3. Number 3 is a little more easier now. Cube root of 125x to the 6th. What's the cube root of 125? So what times itself 3 times is 125? Andy? It is 5. Yep, I get 5. X to the 6. 6 divided by 3 gets me x to the 2nd. So I get 5x squared there. So the cube root of 125x to the 6th is nothing more than 5x squared. Number 4. Recognize. I have 2 numbers. Can I simplify 64 and 2? What's 64 divided by 2 going to give me? 32. So this really becomes the 5th root of 32 over x to the 10th. Does everybody see where I got 32? I just did 64 divided by 2, simplified it down. Now I can take the 5th root. What's the 5th root of 32? So what times itself 5 times will get me to 32? A lot of times you want to start with low numbers, so I'm just going to give you a hint. 2. Yep, I get 2 over x to the 10th to the 5th power, or to the 5th root. So what's 10 divided by 5 get me? 2. So I have 2 over x squared. And I'm done there. Number 5. I have the cube root of 2x times the cube root of 4x squared. I'm going to want to multiply those first. What's 2 times 4 get me? 8. X times x squared gets me x to the 3rd. So now I need the cube root of 8. What's the cube root of 8 going to get me? 2. 3 divided by 3 gets me x to the 1st. I don't need that first power. It's just 2x. Question, Phil? Where you at?
I got like I get what you get 3 square root of x or 8x to or 8x cubed, but I don't know how you got how did you get to like 2x?
Okay. The cube root of 8. Now remember, cube roots, square roots, all that means like what times itself gets to that number. So the cube root means what times itself 3 times gets me to 8.
Okay.
So like 2 times 2 is 4, times 2 again gets me to 8. And then the exponents, I just divide it. So like right here, 3 divided by 3 gets me 1. I don't need the 1 exponent there, so I just leave it off. if that were a 21, if this was like x to the 21st power, well, then I have x to the 7th power. I'm just going to divide it every time. Yes, sir?
So you get from 8 to 2, it's the cube root, but which 3 do you go off of? Taking the cube, exponent outside or one on x?
Oh, the one on the outside.
Okay.
Always the one on the root. Thank you. Good question. Yep. Number 6 here. The fourth root of 625 x to the 8th. What's the fourth root of 625? Again, start low. 5. Think of numbers that are compatible. Like if it ends in a 5, what do you think it's probably got to be? Something with a 5, right? So the fourth root of 625 is 5. And then again, I look at my exponents here. What's 8 divided by 4 going to get me? X to the 2nd. So that's nothing more than 5x squared.
So it's exactly what I thought.
Yes, that's exactly what it is. Yes, sir.
Would it ever, is it always going to be like, they just cancel out and be 1, or it's going to be like division for the exponents?
Sometimes
Like, would it ever be 4 and 5? Like, ever?
it can be.
So then,
Great question. So what he's saying here is, what happens if, I'm just going to make a new problem up, is that right? So if I have like let's go the fourth root of x to the 5th. Does that work for you?
yeah.
Okay. This is a little bit tougher problem. You're going to do the same thing. You're going to divide it. So if I take 5 divided by 4, how many times is 4 going to 5? Once, right? Does everybody agree with that? It goes in one time. So I pull an x out, and I'm going to be left with the fourth root of x then. Basically, it's like the leftovers on the inside is what that means. Think of like when you divide. Like remember when you divide, like 5th grade, 6th grade division, when you had remainders? Your remainders stay inside. So I take 5 divided by 4. I have 1, and what's my remainder? 1, right? So I have 1x on the inside.
So you literally just manipulated by the cube.
Yeah. It's real, and everybody kind of looks at this and they're like, and that's supposedly simplified? Yes, it is. It looks longer and it looks more confusing, but that is the simplified version of that. I don't think we'll get into that till I think that's more tomorrow. But yes, you could get some of those. You'll have some of that with numbers today, and you'll just fine, just leave it as numbers. Okay. The next part here, we're going to talk about rational exponents now. We have talked a little bit about rational exponents already when we did solving them. Remember, a rational exponent is the same thing as a radical. For instance, we had problems like the square root of, x plus 2 equals 10. And we always talked about what undoes a square, what undoes a square root, a squared. Well, then we have the same problems, x plus 2 to the 1/2 power equals 10. Well, how do you get rid of a 1/2? You take it to the squared power. It's the same thing. Okay, a half power and a square root is the same thing. A 1/3 power and a cube root are the same thing as well. A 1/4 power and a 4th root are the same thing as well. Okay, so what we're going to get into now a little bit tougher rational exponents, like 64 to the 2/3 power. Now, when you have a lot more difficult problems, you can type this on your calculator. Okay, you'd have to do like 64. It depends on your calculator, caret or whatever you have, to the 2 fraction thirds power, and you would get a correct answer. Okay. Another way to look at this is you can break it down. The denominator part of this, my thing right there is not very good. Okay. The denominator part of this is my root. So if you look here, it's 64 to the 2/3. The 3 there, that is my root power. So it's like saying the cube root of 64, and then I would square it. So you have to take it kind of step by step. I would do first the cube root of 64. Cube root of 64 is 4. And then I would take that 4 squared, getting me 16. Okay. Same thing here with negative 32. A little bit tougher with negatives, but same thing. I would do the 5th root of 32, which is 2, and then take 2 to the 4th. Again, we have higher numbers, a little more difficult. You can use a calculator all the same to get you the exact same answer. You just have to raise it to a fraction of a power, is what that means. All right. Then here's kind of what this looks like. So again, the nth root goes to the denominator essentially, and the exponent on the inside goes to the numerator. All right. So let's look at a couple of these here. Number 7. I have 27 to the 4/3 power. 27 to the 4/3 power means my denominator here, my denominator is my root. Okay, my denominator is my root. My numerator is my power. And I'm going to take it step by step on this, essentially. So I have to think, first of all, what's the cube root of 27? What times itself 3 times gets me to 27? It is 3. So I get 3. And then I take 3 to the 4th power. I would take 3 to the 4th power. Now 3 to the 4th power, 3 times 3 times 3 times 3, and I get, what is that? 81. So 27 to the 4/3 power is nothing more than 81. Okay? The toughest part about this is just kind of thinking about the root is your denominator. Okay, you have to take it step by step. So 49 to the 3/2 power. Well, that's like saying the square root of 49 to the 3rd power. Now, notice I didn't have to put a 2 out there because it's a square root. There's that invisible 2 power. So I have the square root of 49. What's the square root of 49? 7. Square root of 49 is 7. So I end up with 7 then to the 3rd power. 7 to the 3rd power comes out to be what, Andy? Anybody? 7 to the 3rd power? 343. It is 343, actually. Yep. Okay, try number 9. Try number 9. Take a couple seconds, try number 9. 16 to the 3/4 power. So if you broke it down, it would be the 4th root of 16 to the 3rd power. 4th root of 16 comes out to be what, John? 2. And then 2 to the 3rd power comes out to be 8. So my answer there is 8. Nice job, sir. Now, number 10. It says write each expression as a rational exponent. A rational exponent just means like a fraction exponent. Okay? So when we had problems like this, for instance, if I had, let's go the cube root of x to the 12th. What was the cube root of x to the 12th? It was x to the 4th. What did you do there? You did what, John? You just divided, right? Well, to take it from a radical expression to a rational expression, what are you going to do there, John? Same thing. Divide. All the difference is you can't really divide the number, so you're going to leave it as a fraction. So I have the 5th root of 4 squared. To write that as a rational exponent, it's nothing more than 4 to the 2/5 power. All that is. To write that as a rational exponent, you just basically divide by that root, or the radical part. So that's 4 to the 2/5 power. And you're done there. Same thing on 11. Now 11, they do not give me a root, and they do not give me an exponent, because they're both invisible. What's my invisible root here? Invisible root is a 2. My invisible exponent is a 1. So the square root of 19 as a rational exponent is 19 to the what power? Half. Yeah, this is 19 to the 1/2 power. Nice job. Try number 12. The 4th root of 6 to the 5th power. Again, write that as a rational exponent. So again, rational exponent just means fraction. How would that be as a rational exponent, Jack? 6 to the 5/4 power is correct. Nice job, sir. That's all this. Yep. Either way are technically correct, I think. All right. Simplifying expressions here. Let's try number 13. So I have 24 over 3, x to the 3rd, all to the 1/3 power. Now, if it's to the 1/3 power, what's that the same thing as? 1/3 power is the same thing as a what radical? cube radical, right? So this is the same thing as saying the cube root of 24 over 3x to the third. Because it's a 1/3, it's like putting that 3 back out in front. It's the same thing. And now I can simplify this. What's 24 divided by 3? 8. So I get the cube root, cube root of 8 over x to the third. What's the cube root of 8 then? Cube root of 8 is 2 over 3 divided by 3 gets me x to the 1. So I have 2 over x. 2 over x is correct. Number 14. What do you notice about these two radicals here? Are they the same? No, I have a square root and I have a cube root. So I need to simplify each one first. I can't multiply them. I have to simplify first and then I can multiply. What's the square root of 49 come out to be, Maddie? 7. Times. Cube root of 8 is what, Shane? 2. Cube root of x to the 6th. 6 divided by 3 gets me x to the 2nd. So I have 7 times 2x squared. 7 times 2 gets me? 14. I get 14x squared there. 15. I believe you'd want to divide those first. So you want to divide that. 117 divided by 13 gets me the square root of 9. Oh, thank you. Okay, thanks. Square root of 9. What's square root of 9 simplify then as? 3. And that's that.
17 doesn't seem like
What?
117 doesn't seem like
Remember the old rule though? If you add them up and they're divisible by 3, the numbers are divisible by 3. If you add them up and they're divisible by 9. So you can say 1 plus 1 plus 7 is 9. So it has to be divisible by 9 and 3 then technically. You don't remember that rule? You never learned that back in...
No, I never.
Never? Like if it's an even number, it's divisible by 2. If it ends in a 5 and a 0, it's divisible by 5.
I think people know the by 2.
Yeah.
If it's divisible by 2 and 3, it's then divisible by 6. You never learned all this?
Well, I guess you pick that up somewhere along the way, but it's never taught.
Yeah. That's like 5th, 6th grade math probably. Try these two. Or sorry, try these 4. Write each expression in radical form and simplify. 17 does not come out evenly. And neither does 19. So just write it in radical form. 16 and 18 you can simplify all the way down. Alright, let's look at number 16 here. 8 to the 2/3 power gives me what, Andy? It is 4. Oops, wrong one. Yeah, it comes out to be 4. That would be like the cube root. Ooh, there we go. The cube root of 8 to the 2nd power. So the cube root of 8 was 2. And then I take that 2 squared, and that's what gets me 4. Okay. 17. 5 to the 4/3 power. It doesn't simplify. You just have to write it as a radical form. How'd that be as a radical form, Jack? What would be my root? The 3 or the 4? Which one's my root? 3. So that's like the cube root of 5 to the 4th power. Or you could say the cube root of 5 to the 4th power. Those are the same thing. Okay, either one of those are the same. What about number 17? Or sorry, not 17. 18. The square root of 7 squared gets me what? Sean, tough one. What is it? 7. Yeah, I could do 7 squared, which is 49. And then the square root of 49 is still 7. Nice job. And then 19. The 4th root of 5 to the 3rd power. Just write it as a rational exponent because you can't simplify it. What's that going to get you? Mark?
I still know how.
As a rational exponent. Rational means what?
I don't know. I'm still confused.
What's a rational number mean?
Has a whole number.
Rational number means it's usually a fraction. So a rational exponent means it's a fraction. So to write that as a fraction, my root goes to where? My denominator, right? So to write this as a fraction, you would say 5 to the 3/4 power. That's all that is. That's a rational exponent. Just taking the radical and putting it as a fraction, basically, as an exponent. So I could say, well, that one's up there is already done already. Like the square root of 7 to the 3rd power. Well, that's like saying 7 to the 3/2 power. It's just dividing by that root as an exponent, basically. That's all that is. Try these 4. Same idea. Simplify them. Simplify the radicals first or simplify the roots first. Either way, you go about simplify these. All right, let's look at 20. A couple ways to do it. You could have multiplied, added exponents, and then simplified, or simplify it first and then multiply. Either way you work it out, you get an answer of what, Phil? 32. Yep. You could have gone 4 times 8, or you could have said 2 to the 5th equals 32. Either way, you get 32. 21. You'd want to simplify the radicals first, and then do the square root. So when you simplify, you get the square root of 4 over x squared. The x squared stays in the bottom. And then I simplify the radical. Square root of 4 gets me 2. Square root of x squared gets me x. I have 2 over x. 22. The square root of 25x squared, all raised to the 3rd power. Again, take it step by step. Square root of 25 is 5. The square root of x squared is x. And I take that all to the 3rd power. 5 to the 3rd power is then. So I end up with 125x to the 3rd power. There's not a 23. You are correct. Didn't like that problem. It's bad luck. Which one?
13.
You had 10. It's even worse for math. 24. Cube root of 8x to the 3rd power. What's the cube root of 8? John? Cube root of x to the 3rd is? Just x. So I'm left with 2x. And that's it right there. Okay, good work. The biggest thing is make sure you understand how to simplify, break down a square root or a cube root of a number, 4th root. The exponents are a lot easier because you just got to divide them, basically. You're just dividing by the root. Here's your assignment.